Okay, this is a short video on a hp8443a tracking generator. It's not going to win any Emmys. We've got the output of the tracking generator connected to the input of the spectrum analyzer. The tracking generator is in track analyzer mode, which means that as the frequency is swept across, the output frequency is being swept in step with that. And what we see is a flat line. And I hope you can see that, but it is there. So that's one mode of operation. I currently have the analyzer in sweep from essentially DC to 100 megahertz mode in this test, showing the flatness over 100 megahertz. Now what I'm going to do is put in a low-pass filter. And hopefully you can see now the pass band of the filter, and it drops off like a rock, and it's down about 80 dB. I've got the analyzer set to plus 10 dBm full scale. I've got the output of the tracking generator set to 0 dBm full scale, so we're down one division. And I'm now going to switch to scan width mode rather than 0 to 100 megahertz. And we'll see the other one fade out. And here's the new trace here, and this is now the filter response with a 25 megahertz center frequency and a 50 megahertz span. And of course we can diddle all these controls and zoom in and do narrow band filters and whatever, but it's a poor man's network analyzer is what I'd call it. So that's one mode of operation. The other mode of operation is the restore signal mode. So what we're going to do is take the filter out and we're going to connect the spectrum analyzer to the cal output, which is at minus 30 dBm and 30 megahertz. You may be able to see that. What we're going to do is change the center frequency now to 30 megahertz. And also up the sensitivity of the analyzer. And narrow down the bandwidth of the sweep. Yes, a bunch of changes here. Okay? So what you see in the reading here is 29.99, and that's because the cursor of this guy is set to the center frequency. But when you put it in the restore signal mode, what you see is 30.00036, because this is actually now measuring the signal, not just measuring the oscillators in the spectrum analyzer. So it restores the frequency of this signal. So if I were changing this signal, which is equivalent to changing the spectrum analyzer, you see that this reading does not vary. But if I take it off of restore signal, you will see, here we are at 66, 966, 97, 98, 99. I'll dial in 30. Okay? But put it back to restore signal, we get the actual value of this within the accuracy of the time pace of this guy. Okay, now, if there are problems with this system, the problems, 99 times out of 100, are the interconnect cable. And what I'm going to do is go back to the track analyzer mode, lower our sensitivity again. Finally. Okay, now we're going to go the full 100 megahertz span. Flat line. This is one of the times where flat line is a good line. Okay? Flat line. That little bit is the center frequency setting of the analyzer. It's a marker. Okay, flat line. Now, trouble. The trouble comes from intermittent connections in these cables. There's only one, but if I wiggle this, you can see that anomalies can develop. Okay, so I think it is just dirty contacts in both the analyzer and the end of the cable. So, and there is no restraint on that connector. So that is the #1 cause of problem, aside from operator error. So there you go. We made it through. There was a faux pas in there, my error. You have to know how to connect the wires, don't you? And just to show and tell that this guy is working very fine. End of sermon.